Hello, I am Edward Berman. I'm going to be talking to you about confidence intervals and their relationship with hypothesis tests. As an overview, I'm going to give you a problem statement where we are asked to explain something. I'm going to explain why it's difficult to explain. I'm going to answer it and give some more and elaborate more on the interpretation. And sort of give a proof sketch that'll help you gain an intuition about this relationship that I will describe. So we have the following problem statement. For normally distributed random data with unknown mean and known variance, explain the relationship between the 95% confidence interval, the unknown mean, and a hypothesis test for the unknown mean. This is difficult because we have to think about running a random experiment several times and think about where a mean typically is. This can be confusing because the mean is already an aggregate of data. But as an answer, for normally distributed data, a hypothesis test will tell you whether or not your predicted mean is likely. In other words, I have some confidence interval that tells me that the mean of an experiment will fall within a certain range 95% of the time. 95% is in some sense arbitrary, but it's an industry standard. And when you're doing statistics, it is important to keep in mind that we're not trying to reinvent the wheel. We are just trying to gain information about the world around us. So if I change something about this experiment, maybe I'm trying to test if a new tire gets more mileage and I stay within this interval, I fail to reject the null hypothesis. So the null hypothesis, as the name would indicate, is that it's nothing. It won't make a difference. You could achieve the same result by random chance. So if my new mean after I change the tire stays within this interval, then I fail to reject the null hypothesis. That is, I cannot deny that there's a chance that my new tire makes no difference. However, if I change the tire of my car and I fall outside this interval, then I can reject the null hypothesis. There is evidence to suggest that my new tire makes a difference to the mean. However, this does not mean that I am accepting the alternative hypothesis. It just means that I'm rejecting the null hypothesis. Um, some more about this interval. It is given by the following expression: x bar plus or minus z of alpha over 2 times sigma over square root of n. I'll explain a little bit more about where this comes from. But a little bit as an interpretation of what this means. We cannot accept any hypothesis to be certain always. We can only compare two hypotheses. We can only say that a mean is more likely, one mean is more likely than another to fit some data. So a little bit about where this confidence interval comes from and about our knowns and unknowns. We don't know the mean, but we know the sigma. So this will tell us a little bit about how about the area that our normal distribution makes up. And we want 95%. So we have these two regions, each taking up half area so that we integrate. This will come out to be 0.95. So the mean will be within this region 95% of the time. And if it's outside, then we can reject the null hypothesis that our alteration of the experiment doesn't make a difference, that should stay in here. Going back to the car example, if it stays within here, well, if we didn't change anything about the tire, the mean would be within this region. And so if our new tire was still within this region, then we can't say with any certainty that our new tire would have different. If it does, well, this is much different than what we would expect if we didn't change the tire. So we can reject the null hypothesis. Thank you.